All right, we're going to take a look at the 1.3 day 2 homework. So number 9, I did not assign the other day from the previous assignment because we didn't get a chance to talk about natural logs. So I'm going to go ahead, we'll take care of that one right now, and then we'll move into the rest of the problems. So like we talked about, we're supposed to just know these derivatives. As soon as we see cosine, we're supposed to know the derivative of cosine is negative sine. Now, whatever the original inner function inside the cosine function was, is the function that then appears inside our sine function. And now I need to take my derivative of natural log of x, which we discussed in class as 1 over x. We have one step of simplifying to do. We're going to go ahead and multiply the sine of natural log of x times the 1 over x. And whether you leave the negative in front or whether you put it up top with the negative sign, that's up to you. Number 2, like we've talked about with coefficients, we just bring the coefficient down and multiply it by our derivative. As soon as we see secant, we know that the derivative of secant is secant tangent. It's just a matter of what was inside the secant. In this case, it's x to the 5th, so I'll put my x to the 5th inside my secant and my tangent, and then I need my derivative of x to the 5th. I always simplify monomials, so I'll multiply the 4 times the 5x to the 4th and end up with 20x to the 4th, secant of x to the 5th, tangent of x to the 5th. Like we would have discussed in class a couple times, when we see that we've got our trig function squared, I highly recommend rewriting it with the square outside the trig functions. It really helps us to see that we've got 1, 2, 3 functions we need to take the derivative of. So I know that the derivative of anything to the second power is 2 times that something to the first. Well, that just so happens to be cotangent of sine of theta. From there, I need my derivative for cotangent. I know the derivative of cotangent is always negative cosecant squared. It's just a matter of what's inside, and in this case, it happens to be sine theta. And then finally, I need my derivative for sine theta, and that would be cosine theta. Just do a little bit of simplifying. The negative lead coefficient needs to get multiplied by the 2 to get us our final answer. Number 6, once we see natural log, we know that we need 1 over the original function that was inside times the derivative of that inner function. So in this case, I end up with 1 over my cosine theta times the derivative of cosine theta, which is negative sine theta. Now, if you don't happen to notice the trig identity, don't worry about it. But when we multiply negative sine theta times 1 over cosine theta, we actually have tangent theta. Again, I'm not going to worry too much about trig identities, so if you didn't notice that and left your answer here, that's okay. Again, here's another case where we see that that trig function is squared, so I highly recommend you rewrite it emphasizing that you've got the entire quantity squared. We know the derivative of anything squared is 2 times that anything to the first power. Well, what is inside that value being squared? Tangent of 3 theta. Once I see tangent, I know the derivative of tangent is secant squared. And then the only thing I haven't taken the derivative of is 3 theta, and that is 3. Always multiply monomials together, so we end up with our final answer, 6 tangent 3 theta, secant squared 3 theta. And then finally, I rewrite my 5th root of natural log of x as natural log of x to the 1/5. I know that the derivative of anything to the 1/5 power is 1/5 times that anything to the negative 4/5 power. That original inner function happens to be natural log of x, so I take its derivative, which is 1 over x, and then I've got just a little bit of simplifying. All right, we're going to see the chain rule almost every time we take a derivative, so these rules really aren't going away. The transcendentals you start to become more familiar with the more we do them, but again, it is just a matter of memorizing them.